Hi, kids. Okay. Hey, it's a little bit dark in here because I wanted to show you our $700 demo because really this is the key to drawing ray diagrams for both convex and concave mirrors. So let's talk about that. So if you guys take a look, I have my mirror here. So you can see on this side it caves in, so that's the concave side. But if you look, if I have light rays coming parallel and they hit this, you can see that the light rays meet at a point right there. The light rays really go to that point, okay? That is called a real focal point because the light rays really go there. If you can remember this, okay, versus this, that's the key to everything, okay? The concave side, the light rays really go to there. It's coming together. Converging. It's a converging mirror. It's going to have a real focal point. Hopefully you can see that. Versus the convex side, the side's vexing out. If I draw this, you can see that, hey, the light rays don't meet over here. But if I was to trace them back on this side, it would seem like they meet over there. The light rays are not actually coming from back there. It just seems like they are. That is a virtual focal point. So if you guys can remember that, that's the key to drawing all the ray diagrams. So like if I was to, sorry, I'm kind of close here. Let me scoot that back just a little bit, okay? But if I was to draw just that picture, that's the key to everything. So concave mirror, light ray comes in, and those light rays bounce off. Remember, they have to follow the law of reflection. Angle of incidence equals angle of reflection, normal line, and then that would be my focal point. Okay? And when you're drawing your ray diagrams, it's the same thing. It's just like, hey, if I'm going to draw a ray diagram for this, if I sketch it over here, if I have, here's my focal, remember 2 times the focal is going to be my center of curvature. But if I was to draw that in, hey, parallel, it's going to go through the focal point. And then if I can remember that, if I do that in reverse, focal point, it's going to come out parallel. And then, hey, look, I already know where they're going to meet. It's going to meet right here. But if I wanted to do my third one, there's a whole bunch of ways you could do it. You could have it hit in the center, and then bounce off angle of incidence, angle reflection. Or I think probably the easiest one is just, hey, I'm going to have it go through my center of curvature, and this is the one that goes straight back. They all meet right there. There is my real image. Remember, if we show our amazing $700 demo here, that if you have an object that's before the focal point, so you had a picture that looks something like this. So if here's my focal point and I have an object that's here, well, if you look, guys, and this should make sense, okay, if you put your object in here, well, the light rays haven't had a chance to bounce off, and they haven't had a chance to reverse to go the other side. So if I do my same light rays parallel through the focal point, and then if I go through the focal point and then parallel, it's like, hey, they don't meet, but if I extend them back, they do meet. Hence, it's a virtual image. So there you go. Versus a convex mirror that's vexing out. Okay, if I draw my light rays coming like this, the light rays diverge, but again, normal line, angle of incidence, angle of reflection. If I was to extend these back, they seem like they meet back here. That would be a virtual focal point, okay? Which is, again, if I do this, it seems like they're going to meet back here someplace. If you draw your ray diagram, that's the key to everything. So it's like, hey, you know what? You know, there's my object. If here's my focal, there's this one. The light ray bounces this way. I'm going to go towards the focal. So I would go towards it. It would bounce off straight. If I extend it back, hey, there's where they meet. And then if I wanted to do my third ray, I could, which would just be this guy, and it would extend back. Or go towards the center curvature. So just remember $700 demo, and that's going to be the key to everything. Bye, kids.